Good day, everyone. Thank you for joining our third test talk session. My name is Jean-Marie Vilain. I am a product line manager at EXFO, and in this session, I will be your host and moderator, covering this great subject of new era transceivers and 400 gig and beyond. But before we start, I would like to cover a few housekeeping points. The first one is for optimal viewing quality, we recommend using Google Chrome as a browser and closing any other program running in the background. Also, please note that the chat will be open during the session, so feel free to post your question in the chat during the presentation. Also, after this live session, we will also invite you to join our in-depth technical session with our subject matter expert and also two new guest speakers. Without further ado, I would like to introduce our today's guest speakers. Our first guest, David Rodgers, is a senior product marketing and program manager at Teledyne LaCroix, and also board member at the Ethernet Alliance. In his role, David is responsible for defining, designing, and marketing a broad bench of high-speed serial analysis tool for storage solution. David has been in the telecom industry for over 35 years. Welcome, David.
Thank you, Jean-Marie.
We also have with us Faisal Dada. Faisal is a principal architect and director in the wireless and wired group at Xilinx. In his role, Faisal is responsible of the optical transport and access global market and works closely with the product planning team to define new and next generation products. He also works with the key standard bodies. Faisal has more than 20 years experience in the industry. Welcome, Faisal.
Thank you, Jean-Marie, and thanks for the opportunity.
Thank you. Last but not least, we have Leo Lin. Leo is the director of the NEM Manufacturing Design and Research at EXFO. Leo has held various leadership roles in product management, sales, marketing, and engineering to launch multiple products family. Leo has more than 20 years of experience in the telecom and IT industry. Welcome, Leo.
Thanks, Jean-Marie. Glad to be here.
Thank you. So now let's get into our subject. The topic of our session today is all about the new era of transceivers and 400 gig and beyond technology. With 800 gig around the corner, 400 gig is being widely deployed in R&D environment and are making their way to data center and network operators field implementation. The telecom industry will soon face new challenges in designing, testing, and manufacturing next generation pluggable optics. So today, starting our presentation, we will first hear from David and Leo on these new market trends and how this affect the design of manufacturing. Closely following, we will hear from Faisal addressing the silicon enablement for 400 gig and beyond. We will then review the key 400 gig and 800 gig challenges with David and Leo and open up the discussion and audience questions. So again, feel free to post your question in the chat window during the presentation. At this moment, I would like to pass the presentation to David. David, over to you.
Thank you, Jean-Marie, and good morning. So in the first phase of my presentation, we wanted to introduce what we do with the Ethernet Alliance, and all three of our organizations participate quite vociferously in Ethernet Alliance activities. And we have a few slides to introduce what the Ethernet Alliance is, for those of you who don't know. The Ethernet Alliance is the marketing arm of the IEEE and everything Ethernet, all of our Ethernet specifications in the industry. We have work groups and we have teams that look at how to represent that information in a marketing sense. We don't do anything with the creation of standards, we just do presentation of the standards. The mission of the Ethernet Alliance is to promote the awareness in the industry and advancement of the technology of the evolving Ethernet standards so that we can accelerate industry adoption and make it easier for the deployment. And one of the key things that we do is provide resources to create and demonstrate multi-vendor interoperability. Next slide. Do I have control? No. Okay. So these are the key features or the strategy points behind the Ethernet Alliance and what we do. Again, I facilitate interoperability testing. We do plug fests, private plug fests. We do public demonstrations of our technology. And this is so that we can assure interoperability. We've even gone so far as to release the PoE, the Power over Ethernet certification program to the industry, which is widely received very well for making certain things interoperate. We do collaborate with other industry organizations so we can have consolidated messaging and make certain that we're kind of moving the Ethernet ball collectively forward. And that includes a global outreach with worldwide members, as evidenced by some of the people on the call today. We are literally in multiple different time zones in different countries. We recently hosted the Technology Exploration Forum. It's part of the thought leadership, the way we bring our experts together, not unlike what we're doing here today to talk about things that are going to challenge us. And lastly, it's the promotion of Ethernet. Not that it really needs a lot of promotion, but there's a lot of things about Ethernet that people look at and they go, oh, that's Ethernet. Well, how does that fit into the ecosystem? So education and the marketing of those solutions is very important to us. Next slide. So if there was only one thing that the Ethernet Alliance did, it would be multi-vendor interoperability. And I've highlighted in the bullet points here some of the things that we do. And in the graphics on the right, all three of our organizations have met and performed at these demonstrations, public demonstrations, like at OFC. The last time this group of people got together was in the spring of 2020 to do our OFC build out for interoperability. And of course, the lovely COVID vaccine took that out, the wind from our sails on that. But public trade shows, and that could be for single pair Ethernet or high speed stuff. It's very important that we show how all of these things work together. Next slide, please. We produce regularly a roadmap, and the Ethernet speedometer used to be a roadmap, literally, but there's too many things, there's too many branches, so we put together the speedometer for application spaces. And the reason I'm representing this on the presentation today is you'll notice that no one technology fits nicely in one pie slice. Technology is across the board. So in a data center, you're going to have low-speed IoT devices that are connecting to the high-speed fabrics as well. Next slide. The roadmap itself, and this demonstrates, at least in my mind, for the first 10, 20 years of Ethernet, we rolled along rather slowly with the advancements of 10 meg and then 100 meg and then 1 gig. And then we got to 10 gig, and it was a major, it was a big deal. Now we're moving forward at rocket speed, if you will, to get to 100 gig single lane, the holy grail of the SerDes, to get us to 400 gig and 800 gig in condensed QSFP DD or OSFP connector spaces. So we're rapidly moving Ethernet speeds forward as a technology and in the industry jointly, or together, I should say. So next slide. This is a picture of one of our last interoperability demonstrations. This was OFC of 2019. And the reason I presented this for you is it really truly is not only a Ethernet Alliance and member activity, but it's a group activity. We all have to come together in the industry to make things work. Test measurement, interconnect, servers, silicon. So, I mean, today's test talks is representative of that very much so. But we had 21 members participate in our last full interoperability demonstration, and we actually had live interoperability going on with 400 gig drops from booth to booth in the San Diego Convention Center. The group on the bottom right is the group that comes together at offline to make it all happen, and it's a regular cadre of ne'er-do-wells in the Ethernet industry that come together to make things work. And I think our last slide for this portion of the deck is, if you're interested in the Ethernet Alliance, you'd like to learn more about what we do and join on, these are the ways to contact us at the Ethernet Alliance. Our website is replete with all sorts of information, including downloads for the Ethernet roadmap, the Technology Exploration Forum information that we just had in January. Check it out if you haven't already, and if you're not already a member. Jean-Marie, I throw it back to you. Thank you.
Yes, thank you, Dave. And now we'll be moving to Leo, which will again highlight the trends and market innovations.
Okay. So actually, thanks, David, for the overview on the Ethernet Alliance. It's actually, interoperability is definitely a crucial one for our industries. So let me continue to also share a little bit on the latest market trend and industrial trend to kind of see where we stand in this kind of evolution to higher speed. Next slide, please. So first, let's take a look at the market trend. So this is the Ethernet transceiver trend from one of the recent light counting report, and this is the trend is being broken, kind of breaking up based on the data rate, and it is based on the transceiver optics sales in dollars rather than in volume. But I think it's quite important to see the trend in the optic sales because it really demonstrates where the industry is investing their money on. So from the trend, it's quite obvious the transitions of shifting the focus from 100G to 400G that's already happened. And 400G will definitely be the driving force for the market in the next couple of years. But it's also very interesting to start seeing that 800G has also started to surface, and this 2 years, and then will continue to increase in investment through the next 3 to 4 years. So definitely together with 400G and 800Gs, definitely the higher speed Ethernet transceiver will become the next wave in our industries. Next slide, please. So with this continuous evolution in the higher speed transceiver, it also comes with a set of, you can call it market requirements, you can also call it the pain points or the challenges. Some of the top challenges, including definitely the higher density, the lower power consumptions, and lower cost. So first on the density, right, with the increasing the bandwidth demand, and also with already fully populated the kind of front panel faceplate. So moving to even higher data rate and going to next generations. So higher density or smaller form factors optics is definitely desirable and actually needed. So together with a higher density and now going to higher speeds, that also brings more power hungry components into the optics. So that's not just increase the total power consumption, but also adds challenges in power dissipation or thermal management on the front panel, whereas right now it's already fully populated with very hot pluggables. So then together with this market demand, as well as even more complex technology required in the higher speed and more power hungry components, and then the industry at the same time need to meet these cost targets in order to sustain the growth. So right now, this sub-dollar per gig is actually become kind of industry-wide goal. Actually, all these three requirements or challenges are not new, right? They're actually applicable to all generations of optics until now. But as we are moving to higher data rates, these challenges also continue to grow in complexity and difficulty. Especially, we have to meet all these requirements at the same time, which is a challenge. Next slide. So with these challenges, though there's a lot of challenges, but we are an industry with a group of very smart people. So the industry continue to come back with new solutions to address those requirements, not just increase in speed, but at the same time address these three key technical requirements. In fact, the releasing of a new form factor has actually become a quite common thing in the industry today. But at the end of the day, due to economy of scale, due to efficiency, typically the market will eventually converge to a few dominating form factors. For example, for 100G, QSFP for sure, SFP for 10G, and then for 200G, 400G, mostly QSFP DD and OSFP. So we also expect something similar for moving to 400G and beyond. Definitely there will be introductions of new form factors upcoming in order to support the higher data rate at the same time address these couple market requirements. Next slide, please. So, but behind all these form factors, the main driver is still the application. So in our cases, the main driver for the market today is the cloud or the data center, to be more specific. So they continue to drive both the service migrations and also the optical module evolutions. So you can see from this very simple table chart here that optics have continued to evolve from 10G, 40G back in 2012 and to today it's 100G, 400G, and tomorrow it's going to be 200G and 800G. So this continued push for more technologies definitely increase the challenges for the industry, but at the same time also bring new opportunity for us. So next slide, please. So finally, in order to support this beyond 400G, the optics, there are two standard bodies today overlooking the standards. So one is the Ethernet Technology Consortium, is mainly looking at 800G Ethernet standard. So they are expecting to release a standard in a couple of months. The other group is IEEE. They created a study group focusing on beyond 400G and then with two goals, both 800G and 1.6G, 1.6T Ethernet in mind. So this is a pretty brief updates on the market and the industry. And back to you, Jean-Marie.
Yes. Thank you, Leo. And at this moment, I will be handing it to Faisal Dada. I will go over the component side.
Thanks, Jean-Marie, and thanks, Leo, for that. So if we go to the next slide. So Xilinx has been working hard to bring components to the market, over the last few years, and we built latest and greatest technology. But let me hammer in on 3 points that Leo mentioned in his previous talk, right? Higher density, lower power, and lower cost. And they're critical for the market to go forward from any component provider. That's key because that's what hits the dollar per bit metric. So in our latest generation of parts that you see up here, what we've done is, as a programmable component, we have our old DNA of adaptable engines and adaptable hardware, which is the DNA of our parts. But with that, we've hardened multiple Ethernet max, FEC, SerDes, and transceivers that do 10 gig, 25 gig, 56 gig, and 112 gig, and put that entire component together as a single entity. So that's our Versal Premium part. Just yesterday, the press release went out that we've shipped the first, made first customer shipments of this part. So it's real, it's up, and it's running. And to really hit that dollar per bit target that Leo talked about, all of this integration really needs to happen. Consolidation of the FECs, consolidation of hard IP, more and more transceivers on a single piece of silicon. And what that does is it allows us to reduce the number of components on a board, and that gets you the lower cost. That is the ultimate target here. Power is key too, right? And from people of the old may have gone and said, look, programmable components, how can you get that much density out of a programmable component? And here with hardening, we've shown that we can actually integrate much of the connectivity functionality and have our adaptable engines do the differentiation that our customers want. If you go to the next slide, please. So how do we get physical connectivity for all the rates that Leo mentioned? He talked about 100 gig being the mainstream, 400 being the current market investment, 800 and 1.6 terabits being the future. And then the holy grail being, I want a pluggable interface where the same pluggable can work as 100 gig, could be 400 gig for my mainstream, and be capable of doing 800 in the future. So what we've done is we've taken our chips and put transceivers on them that are capable of doing 32 gig NRZ, 56 gig PAM4, 112 gig PAM4 as well. And then you can take a QSFP DD form factor, as I've shown here, and basically plug in a QSFP 28, which gives you the 100 gig mainstream at 25.78125 gig NRZ. And David, you can correct me if that number was correct, but I'm guessing I was pretty close. 53 gig PAM4 for our newer FEC on the 400 gig modules, and then hopefully hitting the 106 gig PAM4 to be able to get 800 gig on that same form factor. So essentially, the chip not only needs to be able to do all these rates, but what it also needs to be able to do is support different formats of these rates with different reach parameters. And this was the thing that David had brought up with his pie chart, where you have XSR, which is chip-to-chip connectivity, VSR, where you have to talk to a chip to a module, and LR, where you might have to go over backplanes. So the complexity of doing these chips with these rates, as well as doing different reach factors, is quite the challenge. Next slide, please. So if we go down and look into how we achieve beyond the SERDAS, I talked about a bunch of hard ASIC gates that we put, or hard IP that we put as ASIC gates inside our chip. Two of these components really are the 600 gig MAC engine, as we call it, and what this allows us to do is it addresses 6100 gig PCSs or 6100 gig connectivity, 3200s and a 400. And essentially, if you were to plug a QSFP DD in front of this, you could do a 400 gig, two 200s or four 100s exactly using this module itself. Fortunately, we design our IP as a programmable hard piece of IP with many different inputs and outputs in that hard IP. So as the Ethernet Technology Consortium, as Leo brought up, has written up their 800 gig spec, you can see that our FEC engines, our lane alignment, are capable to be broken out by themselves, and ETC talks about two 400 gig FECs. So we can actually address the 800 gig ETC consortium with this chip as well. So prior to the spec actually being published, we have a part that can address that and be ready for it. We've also gone and hardened other elements, for example, crypto core. So for example, in the Ethernet space, we would talk about MACsec and engines that would be able to do up to 400 gig MACsec in the same chip as well. Finally, on the next slide, what you'll see is what applications can we bring to market with two different aspects of the market. So there is the Ethernet connectivity, which is all the clients, all the connectivity to routers, to data centers, to our enterprises, and then the long haul systems, which are transport systems, and for a while, for a very short while, at 400 gig, we had this harmony, if you might call it, where the transport long haul systems were 400 gig and Ethernet was 400 gig and everything was aligned, the stars were aligned, but they don't align, right? Things rotate and things change. So now we can see line systems have gone to 600 gig, maybe even 800 gig. Ethernet is at 400 gig, going to 800 gig. And how would we connect two line systems, for example, which are 600 gig to 400 gig Ethernets? And that requires us to bring things like FlexE, things like very light OTN mapping into the picture, where you can take a 400 gig signal and inverse multiplex it across multiple line rates. Essentially, the same could be done when we are looking at 400 gig ZR systems, for example, that OIF has specified for data center interconnect. And if we now have an 800 gig E signal inside the data center that needs to be transported, say 80 kilometers using two 400 gig ZRs, that needs to be inverse multiplexed as well. So these are some of the applications that you might envision where line systems and Ethernet rates don't drive. But irrespective of how the market evolves, what we will see is things will be different, but we are a resilient industry, as Leo mentioned, right? And we will come up with solutions to be able to address the insatiable bandwidth for the future. Thank you. Back to you, Jean-Marie.
Yes, thank you, Faisal. And maybe before we go back to David and Leo for the challenges, maybe Faisal, I think from what I saw from your slide, so 112 gig electrical was the enabler for 800 gig. Would you say that 224 gig will be the enabler for 1.6 tera?
That's a great question. I've been around for a while, and every time the next SerDes rate gets talked about, it seems almost an impossibility. And the industry solves this problem every time. Yeah, I thought 112 would be the holy grail, and we would not go further. But no, research is going on at Xilinx. The industry is working pretty hard on the industry. Whoops, sorry. The industry is working pretty hard on developing 224 gig. And they're trying to solve how this problem is going to be done, right? So it is going to be PAM4 or PAM6, what the technology is going to be, how the connectors are going to work. Yes, absolutely, we will need a SerDes rate that actually goes to 224 gig to be able to enable 1.6 terabit in the same form factor, which might be an 8-lane OSFP or a QSFP-DD form factor. And we will be working hard on the R&D side at Xilinx, and I'm sure the industry will solve this problem.
All right. Thank you very much, Faisal. And I guess that phone call was to let you know that the 224 was ready. All right, so let's now move to the key challenges. So I will pass again to David. David, maybe, highlighting, we know 400 gig is a challenge on the testing side. We know 800 gig is going to be even worse. So I'll let you cover that and see how you could help the industry with the test equipment.
It's scary. Speed kills. One of the challenges is designing for. So if you want to roll into that portion of the PowerPoint, I we're going with it. But God, Faisal, 224 gig, which is 3 to 4 passengers per vehicle. It's scary. The challenges. I mean, one of the biggest things we've talked about, even at 100 gig, is power. Power and heat dissipation. I've got in a 1U, I've got 48 QSFP DDs, and I'm driving all of this signaling. And let's forget the testing about it as far as interoperability is concerned. What's the power demands? And I know that we're all looking at how do we reduce power? How do we effectively? Of course, the onset of the OSFP was we thought that the octal form factor would be a better way to do heat dissipation, but it's every component now has to be within 5/9 of its capabilities in order for things to work properly, is really what it boils down to at this point. Or the user and the experience of the user will be less than. And adoption and use cases require that all of us along the point, whatever point we are in the ecosystem, are bringing our best product to the game, if you will. So, we all, I shouldn't say we all, but I know our team uses a lot of Xilinx FPGAs. I know, most of the people in the test and measurement industry use them for the purposes of stability and programmability, and we can change the profile of our tools to meet the challenges of the specific test environment. And who would have thought 20 years ago that FPGAs would be used in production type environments? They were designed for speccing things out before you wrote your ASIC or before you spent the time to make some other piece of silicon. I'm gonna use the FPGA as my test bed. Now it's a production tool. We're using FPGAs on a regular basis. So Faisal and the Xilinx stuff has to be better. Our equipment has to be better. The EXFO stuff has to be more on point with the specifications. So as I point out in my perspectives, design for test at this point, because you can't go back in and test it later on if you haven't made it available to figure out that this component is the right component for this, and we just assume it and we don't test for it, we're going to have problems down the road. Couple that with the fact that we have IEEE and the Ethernet Technology Consortium, and a lot of people who are in the same group are working together. How do we bring these in? And I point that out in my next slide here, which is the standards that beget interoperability. Design this stuff for test at the very beginning, because you're going to need to test it. And the analogy I use with my dad, for instance, is when I explain what we do in Ethernet, it's a series of arteries and roadways with vehicles on top of that. And to this point, we've had single passenger vehicles. So at 25 and 100 gig, it's been one person per car, and then we put 4 cars together on the side, and we made 100 gig. We're now asking about 2 people per car, or 3 or 4 people per car, to get to that 800 gig density in a single port. But what's driving this is that Ethernet is ubiquitous. It's inexpensive, relatively speaking. We've got initiatives in automotive. We've got initiatives in power over Ethernet and industrial applications. Of course, commercial and what we spend a lot of time in is the big data center and cloud and big compute and big storage. And storage is what's driving everything right now. If you look at the market trends, whether it's a Hadoop environment or a standard NFS, doesn't really matter. It's all these different transport protocols that are merging, and now we're trying to flesh that out. Of course, NVMe has become a huge driver in the industry right now. But how do I get the Netflix out of Los Gatos' servers and onto this phone faster? That's, it's storing data, it's content distribution. And as I said, standards beget interoperability, but they also, the implementation differences on how I looked at the standard and how you guys looked at the standard may be different. So we have to have this testing, and we have to have this bring together from a test and measurement perspective. Next slide, please. So as from my seat in the test and measurement space, we are continually looking at how to change the tools to meet the demands. With 800 gig or even 400 gig, we were talking about how do you tap a 56 gigabaud signal to get that 112 gig data throughput and not interrupt that signal and become a problem while you're doing the testing. So with the new speeds, 50 gig or 25 gig, excuse me, which was the first blending of the Ethernet Technology Consortium and the IEEE. From a test tools perspective, we brought all those things together. Now we have this expanded auto negotiation and link training just to get the road paved before we put any cars on it. Now we've added to that with 50 gig PAM4, 100 gig PAM4, and to get to a new holy grail of 800 gigabit per port, whether that's OFP or QSFP DD. What we find is that no 2 vendor implementations are the same. They're approximately the same, but especially in just this link instantiation, it's become a major challenge for the industry to make certain that we're all on the same page. And that's where the design for test comes into play more. I know that, EXFO, and we do a lot of work with EXFO and Xilinx, we're kind of talking to each other like we would at one of our plug fests. in as much as this test talk is concerned, because we've had these conversations in the halls of Teledyne LaCroix or in the halls of one of the trade shows we participate in. So I think we move on to the next slide. And relative to the challenge of the auto negotiation, if you will, again, there's no two implementations that are the same. And to get to the network equipment manufacturers so they can build stuff that work, this collective group that you're talking to today, is on the leading edge of these. I mean, I was looking at that press release from Xilinx yesterday, and we're a consumer of Xilinx products in our analytical tools. And I looked at it, man, this stuff it's actually happening, because we're looking at the additional designs in the Versal product line to meet our requirements as a test tool. So we're definitely partners in pain at being first to implement this stuff. We understand the challenges. So I often tell our customers, don't look at your T&M environment as just a provider of a tool. Look at them as a partner in this process that you're going through to develop your products. There's the traditional signal integrity tools, the scopes and the BERTs and things like that. But now we're adding this protocol, and I did it a couple of years ago, the protocol of the PHY. How do these things, it's not just the positions to, I can, on that falling edge, do this thing. There's actual additional data density in that package, as evidenced on the graphic I have on the right-hand side of the screen. So these purpose-built protocol tools are an addition to, they're not a replacement for the traditional tools, but they're necessary with those traditional tools to figure out how we're going to do what we're going to do on this fabric or network under test. And they're essential now at the hardware bring up phase, as well as I get into validation, QA, and software and test environments. With the ultimate goal being able to standardize my testing, make it repeatable and deployable every single time I do something. So, we have a couple of different platforms for different speeds and whatnot. I know that the Xilinx Versal platform or Versal product line will have multiple different packages, but they're all going to be based on certain standard components that are going to be tested. And you look at all those blocks on his chip, each of those, if they're standardized and I can repeat that process across the way and deploy them, it's going to make it easier for everybody along the way. I think we can move to the next slide. And why do we want to do this? Well, because when it comes to deploying the things, we can't have any more of this. We don't have time for that in the industry anymore. So I need to characterize everything that's in the ecosystem, the interconnect, the server guide, the test environments for that matter, and the test tools, because I want to get down to figuring out what the problem is quickly. And, the whole, well, it's your problem. No, it's your problem. The finger pointing doesn't get us anywhere. We have to be able to quickly determine what the problem is, fix the problem, validate the fix of the problem in a timely manner. And I think the validation of that problem resolution is equally as important, if not more so, than identification of the problem. Once you find the problem, you can fix it, but did I actually fix it? And we have such sterile environments at times, it's difficult to know what the entire ecosystem is going to look like. Next slide, please. So in the participation from a test vendor's environment, test tools, we want to look at things from an independent, I jokingly call it the Switzerland test measurement, at least from where I sit. We're an independent observational point of what's going on in the environment. And we're going to combine, it's a combination of the test monitoring tools that are inherent in some of the products that are out there, the generators and the visibility, we get that. And we add to that with the unfettered analysis of everybody in the pool. We are an independent test point, and therefore it's unbiased. As a generator in the industry, we're going to be part of that transaction. We're going to be exchanging information, and we could be part of a problem, if you will, in the bring up of a system or the initial testing of it. So we want to look at things from I'm just going to tap it and I'm going to sniff it and I'm going to provide a full picture of that. So we also have an option for becoming an active participant in the link to do things like jamming and test remediation. So next slide. which and the graphic in both of these two slides points out that it's all together. We can do things with multiple different test points autonomously, so that if I wanted to see, one of the big drivers right now is timing. The 1588 PTP protocol is being used in so many different applications, and I know my friends at EXFO are doing things in the 5G space, and this whole back end is requiring us. So I have to have the ability to contact multiple test points to see and validate that things are moving through the fabric in the network as I want it to. And I have to do this at a bit level. I can't just look at the frames anymore, because the entire stack, I have to look at everything from ground zero all the way up through the application. One of the big things that I'll talk about, or that we feature in our tool set, is the ability to pinpoint, we call it triggering, pinpoint on the problem instead of just capturing a bunch of data and sifting through it looking for a needle in a haystack. The reason we do that is so that we can validate along all the way to each of the different points. So I want to look at something at the auto negotiation, the link instantiation point, and see how we're moving there. Then I want to move up to the MAC layer and the network layer and see what's going on with all the virtualization that's going on. And it's all important, because I have to integrate these things with all the other components that are in that test bench. So the report the output and the JTAGs that I get from a chip on the system versus what the network monitoring tools, what the application is reporting, all of these things come together to create the complete picture. Because as I tell my dad, if you're having a rough ride down the road in your Ferrari, but you don't know what road you're on, you're really doing a disservice to figuring out how to make your ride smoother. I have to know whether I'm on a gravel road or a nicely paved Autobahn, or a dirt road, to figure out whether or not the package in the car is going to get there on time. So I've talked enough. I'll pass it on. Thank you, Jean-Marie. I throw it back to you. Thanks.
Thank you very much, Dave.
Days on this, as you know.
Yes, for sure. So now at this point, we'll be hanging it to Leo. And Leo, I do see a lot of question already on the chat on the current, so I think you'll be going through that in your testing and the challenges.
Okay, all right. So thanks, David, for a very detailed sharing. So let me continue to share some of the challenges in the more on the transceiver level testings as we are moving to higher and higher data rate. So actually, the first challenges that come to my mind is actually today's wide diversity of form factors, and on top of it, continue introduction of the new ones, right? So this not just add challenges on the design, manufacturing, but also on testing. So specifically on testing is that every time there's a new form factor being introduced, then sometimes it's force the user or the customers have the need to reinvest in a new set of test systems, which is could be very inefficient and also quite costly. So what the industry, I believe, really needs more modular and open testing solutions in order to offer this flexibility and also upgradability in order to support these continuous evolutions in the optical interface. So here we share one of the examples from EXFO. It's what we call an optical transceiver system, or OTS. It is a modular platforms with these module pluggables. It's shown in the middle of the slide. So each of the pluggables actually can support one of the specific form factors. So the user then can now buy one single test systems and buy multiple of those pluggables that support different form factors to cover all their transceiver testing needs. Can be ranging from all ranges of form factor, different data rates, as well as different protocols, right? So that way, it's allow the customer to have also the flexibility to continue to keep up with the evolutions and support today's the testing need, as well as having the upgradability by adding a new pluggable in the futures when there's a new form factor being released. So this is quite important to allow the customer to keep up with the latest development, at the same time also reduce their needs to continue to reinvest in the same test systems when the new form factor is released. Next slide, please. So with the higher or with higher speed, also adds challenges on the electrical side. So already in 200G, 400G, PAN4 FACT is already kind of mandatory. So that definitely adds complexities into both the design and testing. So on the PAN4 side, definitely with the 4-level system now, with that reduced the signal to noise ratio by a factor of 3. So adds complexity in the testing, as well as also adds the challenges in kind of testing because of it's more susceptible to the noise. So if moving to even higher data rates, so the industry is now already talking about PAN6 or higher. So that will definitely continue to add challenges to the testing. The other part is more on the fact side for error correction. So right now, there's also facing certain circumstances when some of the symbol error cannot be correctable. That's also due to a more complex design and also more sensitive to noise. So currently the previous standard of using the bird pre-fact bird testing no longer sufficient to predict the fact performance. So together with this type of testing challenges, new generations of test equipment and solution are needed. So please next. Yeah. So here comes the animation. So the new testing tools are needed. So I will give 2 more examples of PAN4 and fact validation tools that can be used to address this increasing challenges in design and testing. Next, please. So first on the PAN4 validation. So again, with the 4-level systems, analyzing and debugging become more complex. And also with the reduced signal to noise ratio, more susceptible to the noise. So a very good PAN4 validation tool is quite crucial, especially when we move into a higher speed or when introducing new form factors. Because both cases, one of the key challenges is to have optimum signal qualities to ensure the performance of the transceiver. So what we show here is one of the PAN validation tool using the PAN histogram. So this is part of our testers systems. So this using the PAN4 histogram to analyze the distribution on all 4 different levels of the PAN4 signals and also the corresponding eyes. So this allowed the engineers to analyze these data and then can go back to identify some of the physical source of the error, and then can also using some tool, for example, using pre-emphasis to fine-tune and then to optimize the design in the lab, and also can fine-tune to optimize the performance of transceiver in the manufacturing floor. So this tool comes with all the tester both in the lab and also in the field. So that actually offers kind of the end-to-end PAN4 validation tool from lab to manufacturing to the field. Next slide, please. So a little bit more on the, next. Next. Yeah, forgot about the animations. Yeah. So for the fact validation side, so again, fact is also required for the higher speed optics, definitely for 400G and beyond. And then with the current more complex, more sensitive to the noise, definitely there are situations when some of the symbol error cannot be corrected by fact. That's especially in the situation when there are long burst and long random errors. So a tool of a fact validation tool is also required. So example that we show here is also part of our testing systems that use the codeword distributions as well as the symbol arrow histogram to analyze the arrow distributions, and then also compare to this error correction threshold. So that allows the engineers to go back to their design to try to find the problem, and then to fine tune, and then allow them to next please, allow them to try to optimize their system, so give them some better fact margins, and then that would also improve their more consistency performance in their devices. So this is another example of the validation tool that can be supported by the test system. And then so for this kind of a test system, if it's a tool, if it's coexist in the same testers, so they can also do both this fact validation testing alongside with the rest of the transceiver testing, allow them to do some correlation between the test results, and then to optimize the design based on that. So that's all the challenges and practical solutions that I want to share today. So back to you, Jean-Marie.
Yes, thank you very much, Leo. Okay, and well, now this time, and again, thanks Faisal, thanks David, and thanks Leo for these great presentation. A lot of good subject. I would like to open the floor now for a couple of Q&As. We have been receiving a few on the chat. Maybe I see one, and that there was some also that were posted to us prior to this. Maybe there's one here, David, on when looking at the Ethernet Alliance transceiver roadmap, we do see a short gap between the new data rates, right? So how do you correlate this with the transceiver roadmap? So we see the Ethernet and 800 gig Ethernet, 1.6 tera Ethernet, and how do you correlate that with these transceivers that are needed for these specific rates?
Wow, that is the $64,000 question, isn't it?
Yeah.
We spend a lot of time. And to Leo's point, that PAM4 signaling that we're talking about is the electrical signaling. The heavy lifting in the optics is taking electrical signaling and turning it into light. And that takes time to figure out how to put all these components together so that they meet the specification and meet the requirements of the application, and do so without consuming a ton of power or dissipating enough heat to make popcorn. So the MSAs that are coming out, and the consortia that are working together on these optics are doing a fine job, and they're doing it as fast as I think they can. But you start to reach some technical limitations on how fast we can do stuff, and there's a cost to this. So one of the deciding factors is, where's the application and when do I have to deploy for this? So I think that there's always going to be a little bit of a mismatch, because as we all know, in Ethernet, copper is still king. People are still trying to figure out, even at 100 gig single SerDes, how much copper can I use before I have to move to either electrically improved copper or optical stuff. So, from a perspective for what we do, all three of us in this industry, we're always challenged with how do we do this? How do we do our jobs as test and measurement tools to make it so you guys can go faster with the products that you're building? And all four of us, are all dealing with essentially the same challenges and in the same customer spaces for the most part. So, I can't stress enough that we have to look at where those test points are along the entire ecosystem, from the first time we figured out that we can make a PAM3 or a PAM4. I said PAM3. We're talking about PAM6. How do I get a half a person in the car? This is what we're challenged with, trying to figure out. How do we do the testing along the way to ensure that each of these individual components is robust enough so that we can get from this electrical signaling that we're just figuring out today, that Faisal's chips are able to implement, to an optic that I can go in and plug into an EXFO and test in a Sierra Net tool to see that it's actually sending the right signal from end to end.
Mm-hmm. Yes, thank you very much, David. Maybe another one here, and I think addressing maybe more Leo and Faisal. There's an approach for coherent pluggables, right? We saw in one of the slides of Leo the interconnection in between data centers being using coherent pluggable like the ZR Plus. So now there's plan for 400 gig ZR. This is already really active. Is there going to be an 800 gig ZR implementation? Also on the 100 gig side, there's also plan to go back and do 100 gig ZR QSFP28 for the 100 gig data rates. I don't know.
I'll take that. I just want to ask, how fast do you want the bag of popcorn to be cooked?
As fast as possible.
So I think we should keep our heads down and march forward as an industry, right? We thought that 400 gig ZR was a challenging project. I think we've seen that it's doable. People have worked hard and got it done. They will work towards something that is 2x that, because you just need more bandwidth. That is just a fact of life today. The challenges are what form factor do you put it in, and how you can dissipate that thermal capacity, right? And the industry has shown resolve that they will solve this. Now, is that going to be a QSFP-DD form factor? Is that going to be an OSFP form factor? Those are things that as we evolve and get to there, we will see. But the reason the OSFP exists today is people thought that the QSFP-DD was not good enough for 400 gig, right? But the industry solved it. So I think it will likely happen. I know people are working towards it, and we should just expect it in the next few years. I don't know, Leo, if you have any differing thoughts.
No, I think it's similar. I think we have seen similar situations in the 10G and 100G, right? So eventually, it's really the optimum solutions that will win, right? So become the dominating form factors, and then there's definitely a lot of pieces going to that, right? Not just the transceiver itself. Everything, all the silicons, all the optics going into it will continue to evolve through years. So I would say it's hard to make a guess right now, but I believe I kind of agree with you. I mean, the industry will just continue to evolve on a component level, on the packaging level, and also on the transceiver level. So at the end of the day, whichever is become the optimum or the dominant solution would be the one that's most cost effective, and that is most have the economy of scale to win at the end. Yeah.
Mm-hmm. Well, thank you very much, Faisal and Leo. And we're getting close to the hour here. So maybe one last little question here. And Leo, it's pretty quick. You may have only 30 seconds for this one.
Okay.
But, there are multiple transceivers coming out. There are current one, and we expect a whole bunch of new different type of interfaces. How is the test equipment adapting to be able to support all of these different type of interfaces?
Right. So definitely, I mean, there are more and more MSA, and then there's different form factors being introduced as we speak, right? So that's definitely the reality. And then they've been introduced definitely for the right reason, right? Addressing some of the, or if not all, the market requirement. So it's kind of what I mentioned earlier. This is a challenge because we don't want the customer to continue reinvest in a new test system all the time. So some kind of a OTS, the opt-in transceiver systems that I kind of mentioned is one possible solution to address that, because that had the flexibility and the upgradability to address today's transceiver as well as tomorrow's new form factors. So I think that's one way to address these increasing form factor situation. Right. Yeah.
Well, thank you very much, Leo. Well, we're at the top of the hour. This concludes our panel session for today. I know there's a lot of questions. We'll make sure that these get all answered after this session. But what I would like to say is, my thank you to all the audience and also to our 3 guest speakers. So David, Faisal, Leo, thanks again.
Thank you,
But this
guys.
is not the end. Yeah, thank you.
Thanks,
But this is not the end. Following this session, we have upcoming 4 interesting breakout sessions, right? With EXFO subject matter expert and also 2 special guest speakers. So Steve Gia, Distinguished Technology of Cable Labs, and Chris Todd, Program Manager at Senko Advanced Components, will be part of the breakout session. And in this session, what I want to let you know, these are run in 2 parallels. Okay, these are run in parallel. So you could actually attend maybe twice. The session are run twice, so you could actually attend 2 of the session at the same time. So feel free to go in this session. There will be a lot of technical, we've been talking about current, we've been talking about test challenges. Faisal did a good work of showing the components that are live now and coming soon. And then again, Dave highlighted what the Ethernet Alliance sees as a vision. So this is key. And then in this session, this breakout session will be continuing. So on my side, this concludes my participation for today. Thank you for joining and stay safe.